The next step we're going to call multi-step equations instead of just two-step equations because there's more things to do. We're going to start by combining all like terms. Then we're going to move all the variables onto one side and the constants onto the other. Remember, variables are things like x, y, m. Constants are things like 7, or 22, or -5. At that point, we will have a one- or two-step equation where we can undo all the addition or subtraction first, and then we can undo all multiplication and division next. So there's no like terms to combine, but I have to make a choice on whether I want the n terms to end up on the right or the left. Personally, I'm going to cancel them out on the right to avoid negatives. I just looked for out of the two coefficients, which one was smaller. This gives me 2n minus 2 is equal to 6. Then I'm going to cancel out any constants on the left by adding 2 to both sides, and I'm left with 2n is equal to 8. Now I'm down to a one-step equation. So I divide by whatever's in front of n, I undo the multiplication, and my final answer is that n is equal to 4. If I wanted to test my answer, I could plug it in to both of these cases. 7 times 4 is 28, minus 2 is 26. 5 times 4 is 20, plus 6 is 26. That works. Here, I can decide that I want to move all the b's to the left, maybe. This gives me b plus 2 is equal to what? Well, when this goes away, don't panic, just put a 0 there. And then I can minus 2 from both sides, and I end up with b is equal to -2. Here I have to distribute and combine like terms first. So I'm going to take that 1/2 and multiply it. So I get 1/2 x plus 3 is equal to 3/2 x minus 1. If I remember my fraction trick, I could do that from the previous section. I multiply everything on the left by 2 and everything on the right by 2. This allows me to distribute, and it's going to end up canceling out these fractions. So this ends up as 2 over 2x, or just x because that goes away, plus 6 is equal to, and this becomes 6 over 2x, or just 3, I can simplify that, minus 2. Now I want all my x terms on the same side, so perhaps I'll subtract an x here, and I'm left with 6 is equal to 2x minus 2. From here I will add 2 to both sides. I have 8 is equal to 2x. I divide by 2. I get that x is equal to 4. That's a pretty sloppy 2. Whoops. Here's another one that might look very confusing and challenging. Just start with one side of the equal sign at a time. Over here, I look at the terms that might be combined. Minus 6 and 4. That's my first focus, is I put those two together. And they simplify, and they become minus 2a. Next, I'll deal with the right. When I distribute, I not only multiply by 5, but the negative comes with it. So I can rewrite this as minus 1 minus 35 plus 10a. Because a -5 times a -2a comes out positive. And you might notice that these are both constants, so I could combine them and get -36 plus 10a. And I could rewrite this if I wanted to, just to have it lined up. And I'm going to send my a terms over to the right. Notice I'm adding a's wherever I see a's in columns. I have 4 is equal to -36 plus 12a. Next up, I might add 36 to both sides. This gives me that 40 is equal to 12a. Then the last step is to divide by whatever's in front of the variable. Now I can simplify that fraction a little bit, and this will be 10/3 if I divide both by 4. Next up, let's distribute. Remember that I'm multiplying -3 times b and -3 times 9. Now I just undo the subtraction first by adding to both sides. I'm left with -3b is equal to 21. Then I divide by whatever's in front of b. This gives me that b is equal to a -7. Here I have like terms, so before I move on, I should combine them. I can write that -5v is equal to a positive 5v plus 5. And this is where some people make a mistake because of the signs, and they subtract 5v and they get 0 and they're not sure where to go. But if you are subtracting 5v on the left, that brings you actually to -10v. Then when you divide by a negative 10, v is equal to negative 5 over 10, or negative 1 over 2. So the negative kind of just floats to the top. There are some like terms to combine on the right side. So this becomes 6m minus 8 is equal to 1 plus 9m. I will subtract 6m from both sides. Notice I'm keeping the m columns together. Then I will subtract 1 from both sides. I'm left with negative 9 is equal to 3m. The last step is to divide by whatever's in front of the variable, which is a 3. M is equal to negative 3. Here's some distributing to do. 3 times y and 3 times 7. If I rewrite this, I end up with 3y plus 21 on the right side. I'm going to minus 2y. That way I get rid of the y's on the left, and I'm left with 3 is equal to y plus 21. Then I'm going to subtract 21 to get rid of that addition. I have negative 18 is equal to y. Just for sake of argument, what would happen if you subtracted 3y instead of 2y? Would that work? Well, you would get negative 1y plus 3 is equal to 21. You would subtract 3 from both sides, and you get negative 1y is equal to 18. You would divide by a negative 1, and you would get that y is equal to negative 18. So the answer is yes. Does it really matter if you subtract the 2y or the 3y? No. Just changes your steps a little bit. Quite a bit of combining like terms to do here, the 10 and the 1, the 7x and the negative 12x. So 11 minus 5x is equal to 11 minus 5x. So after that, if I try to move over my x terms, here's what happens, which is kind of weird. The x's go away, and I have 11 is equal to 11. Is that a true statement? It is. I could try to subtract 11 from both sides, and I would end up with 0 is equal to 0. This is a true statement. But we don't have an answer for x, so what does that mean? Let's try another one and come back to that. I can combine like terms, 12x plus 1x, 5x plus 8x. Notice that I'm combining on the left only, and then combining on the right only, separately. So I have 13x minus 3, and I have 13x minus 4. And there's an equal sign in the middle. Let's say I subtract 13x from both sides. Notice again, the same thing happened. The x's are gone, and I'm left with negative 3 is equal to negative 4. Is this a true statement? The answer is no. If I tried to add 3 to both sides, I would get that 0 is equal to negative 1, which is false. Or even just up here, is negative 3 equal to negative 4? No, it's not. So it turns out, anytime you end up with 0 is equal to 0, like in number 5, you have a true statement. Therefore, there are infinite solutions. And sometimes we call this all real numbers. If you end up with 0 is equal to some other number, like 0 is equal to negative 1, like in number 6, you have a false statement. Therefore, there are no solutions. While most of the time you actually get an answer for these equations, what these situations represent is on a coordinate plane when you have two parallel lines that will never cross. That means no solutions. And in the same way, if you have two lines that are exactly on top of each other, every single point is the same. So there's infinite solutions. Graphically, that's what's going on here. Let's try just a couple more of those special cases with infinite and no solutions. If I combine like terms, I'm left with 5y minus 8. On the left, I take negative 9 plus 1, and I also have 5y minus 8. So right off the bat, when you have the exact same thing on the left and the right, you can pretty well know that this is a true statement, and that the answer is going to be infinite solutions. It only works if it's identical on both sides at any point. So first I will distribute the 4, and I get 8x minus 12. On the right, I can combine like terms, the 3 and the minus 1. This gives me 8x plus 2. If I subtract 8x from both sides, I'm left with negative 12 is equal to 2, which is a false statement. And what that means is there are no solutions. There's no possible x value that I could plug in to make this true, ever. Sometimes we get these really confusing looking problems like this one, where after we distribute, we have 2n plus 2/3. But if we combine like terms, where you have 3 over 2 and 1 over 2n, That's like 4 over 2n. And 1 minus 1/3, that's like 2/3. And notice what happens. 4 over 2 simplifies to 2n. Are these the exact same thing on both sides? This is true. And the answer is infinite solutions. We'll distribute things like 6 and get 6z plus 18 minus 9 is equal to 27. Make sure you stop and combine like terms, so you have 6z plus 9 is equal to 27. Then you can subtract 9 from both sides, so you have 6z is equal to 18. And when you divide by 6, you get that z is equal to 3. I like to think of these as vertical fractions like 3d over 4 minus 1 over 2. It just helps me. And if I want to undo things, I undo the subtraction first. So I would add 1/2 to both sides. At this point, I have 3/4 d is equal to 7.5. And if I want to undo multiplying by 3/4, I can multiply by the reciprocal, 4/3. And this is something that I can do in my calculator, just like this, 7.5 times 4 over 3, using parentheses. And this will give me 10, which is the right answer. Here's another one that requires some combining like terms. So this gives me 3x minus 81. And on the right, I have 3x plus 12. After subtracting 3x from both sides, you'll find that I'm left with negative 81 is equal to 12. Is this a true statement? No. So the answer is false, and the final thing you write down is that there is no possible solution.